Right in the middle of July, your attic is basically an oven. The temperature up there can easily hit 150 degrees Fahrenheit, slowly baking your house from the top down and forcing your AC unit to work in overdrive. The modern solution the industry wants you to believe in? Paying an electrician $500, cutting holes in your roof, and wiring up attic fans that just add to your monthly power bill. But what if I told you that with $30 worth of PVC pipe and a wooden fence, you could build a vertical axis turbine system that automatically vents that trapped heat 24/7 without costing a single dime in electricity? We are talking about pure, reliable mechanics built to outlast a dozen brutal summers. So why have you never seen a kit for this on the shelves at Home Depot or Lowe's? Why is such a simple mechanical truth being completely ignored? We are going to break exactly that down in this video. Before we dive in, if you are absolutely sick of watching your power bill skyrocket every summer, drop the word "free" in the comments below. Let me see how many of you actually want to declare independence from the power grid. Let us get one thing straight right out of the gate. The concept of a vertical axis wind turbine is not some trendy backyard project invented by a guy with a camera in his garage. If you want to see where this exact mechanical technology was born, you have to look all the way back to ancient Persia, right around the 7th to the 9th century. Back then, they built massive vertical structures known as panamones. The engineers of that era did not have access to lightweight plastics, carbon fiber, or modern aerodynamic modeling software. They used simple drag mechanics to grind heavy grain and pump water in some of the absolute harshest desert environments on the planet. These systems were built out of mud, brick, and heavy wood. Yet, they worked relentlessly for hundreds of years before the concept of an electrical grid even existed. The ancients understood something fundamental that we have somehow forgotten today. They knew that you do not need complex gearboxes, fragile electronics, or expensive materials to harness the wind. You just need to capture its raw physical force. That same ancient, bulletproof concept is exactly what we are going to build and mount on your backyard fence. So, how does this ancient machinery actually work in a modern setting? Most people are only familiar with horizontal axis wind turbines. Those are the giant pinwheels you see out on massive commercial wind farms. Those machines rely on aerodynamic lift, just like an airplane wing, which requires extremely precise engineering and very high wind speeds to operate effectively. But what we are building is called a Savonius vertical axis wind turbine. Instead of lift, it relies entirely on aerodynamic drag. Think about it like this. Imagine you are standing outside in a terrible storm holding an open umbrella. When the heavy wind catches the inside cup of the umbrella, it pushes you backward with tremendous force. But if you turn the umbrella around so the rounded top faces the wind, the air just slips right off the curve. A Savonius turbine is basically two halves of a cylinder offset from each other on a central axis. The wind pushes hard into the cupped side, while smoothly gliding past the rounded side on the return loop. This unequal pressure creates a massive amount of rotational torque. The absolute best part about this specific design for a residential fence line is that it is completely omnidirectional. It does not matter if the wind is blowing from the north, south, east, or west. You do not need a tail fin or a tracking motor to find the wind direction. It just catches the breeze from any angle and immediately starts spinning. Plus, it has an incredibly low cut in speed. While huge commercial turbines need a heavy gust just to get moving, a Savonius turbine will start turning in a gentle, 2-mile-per-hour backyard breeze. Now, let us talk about the actual numbers, because the data here is what makes this project an absolute necessity for homeowners. According to the United States Department of Energy, an improperly vented attic in the middle of the summer can reach blistering temperatures ranging from 150 to 160 degrees Fahrenheit. That massive blanket of thermal energy does not just stay up under your roof. It slowly bleeds down through your ceiling insulation, fighting a constant battle against your air conditioning unit. This thermal leakage forces your HVAC system to work 10 to 15% harder just to maintain a comfortable 72 degrees in your living room. Over the course of a 3-month summer, that translates to hundreds of dollars wasted on utility bills. Now, from a purely scientific standpoint, a drag-based Savonius turbine is not the most efficient generator of raw electricity. Due to the laws of fluid dynamics and the Betz limit, it caps out at roughly 15% efficiency in converting kinetic wind energy. But here is the secret that the industry ignores. We do not need high efficiency, we need high torque. Even at 15% efficiency, a simple plastic turbine creates more than enough mechanical twisting force to spin a pulley system or turn a tiny 12-volt permanent magnet motor. That little bit of rotational power is all it takes to keep a ventilation fan running continuously, pulling that trapped 150-degree air out of your attic round the clock. This brings us to the big question. If this technology is ancient, highly effective, easy to build, and completely free to operate, why is it completely missing from modern home construction? Why is your local contractor selling you a completely different, much more expensive solution? The answer comes down to two major forces in the American housing market. First, there is the sheer profit motive of the HVAC and electrical industries. There is zero recurring revenue in free wind power. If a supply company sells you a mechanical, wind-driven exhaust system, they never see you again. Your problem is permanently solved. Instead, they push grid-tied electric fans or wildly overpriced solar vents. Those solar units usually feature cheap lithium batteries and fragile internal motors that frequently burn out after 3 to 5 years, guaranteeing that you will be back to buy a replacement unit. The second massive roadblock is the homeowners association. The modern American suburb has been aggressively standardized to death. HOAs enforce incredibly strict cosmetic rules that demand all utilities remain totally hidden or bought from approved corporate brands. They view a spinning mechanical device on a fence line as an ugly eyesore, rather than a brilliant piece of independent engineering. The bureaucracy of modern neighborhoods would literally rather watch you pay the utility company an extra $200 every single season than let you build a functional, self-sustaining machine in your own backyard. But if you are ready to bypass that corporate system, building one yourself is incredibly straightforward. You do not need a machine shop, welding gear, or an engineering degree. The core blueprint is beautifully simple. You start with a standard 6-inch or 8-inch PVC pipe from your local hardware store. You cut it straight down the middle from top to bottom to create your two wind-catching scoops. You mount those two halves slightly offset onto a solid steel threaded rod. To make the entire assembly spin effortlessly with zero friction, you press standard, heavy-duty skateboard bearings into the top and bottom of your mounting brackets. You attach the entire rig to a basic wooden frame and bolt it securely to the highest point of your fence, where the wind naturally funnels through your yard. From there, you have two distinct ways to connect it to your attic space. The absolute off-grid method is a direct mechanical link. You use a long rubber drive belt and a simple pulley system to physically connect the spinning rod directly to an exhaust fan blade located inside your attic vent. There are no wires and absolutely no electricity involved, just pure kinetic transfer. The second, slightly more modern way is to attach a small permanent magnet direct current motor to the bottom of the threaded rod. As the turbine spins the motor shaft, the motor acts as a miniature generator, sending a slow, steady 12-volt trickle up a thin wire to power a standard computer cooling fan mounted inside your attic vent. Either way you choose to build it, the total cost for all the raw materials at the hardware store is going to sit comfortably under $40. The biggest takeaway here is that sometimes the absolute best technology is not the most complicated one on the market. It is the one that relies on the unbreakable laws of physics and operates totally free without a monthly subscription fee. True energy independence does not always require massive roof-mounted solar panels or incredibly expensive battery walls in your garage. Sometimes, taking back your independence just starts with a clever little mechanical project in your own backyard, using hardware store parts you bought with cash. We are currently using 21st century thinking to pay heavily for basic problems that the ancients solved for free over 1,000 years ago. If you value this kind of practical, forgotten knowledge, hitting the subscribe button is the easiest way to ensure this kind of information keeps surviving the algorithms and reaching people who need it. And if you want to see another forgotten project that entirely rethinks how we cool our homes naturally without air conditioning, click on the video right here.